Hey everyone, welcome back to Astrum Origin. I'm James Vince, and if you're new here, this is the place where we dig into the biggest mysteries of space, one story at a time. Today we're heading to Mars for something that feels a lot like a detective story. When a detective wants to crack a case, they follow the money. When scientists want to crack the biggest mystery on Mars, they follow the water. Because if water once flowed on that planet, then somewhere in its dried-up riverbeds and crater floors, there might be a trace of ancient life waiting to be found. For that job, science needed detectives that don't get tired, don't complain, and remember everything they see. That's exactly what rovers are built for. So let's look at three of them: Opportunity, Perseverance, and China's Zhurong, and how each one helped prove that Mars wasn't always the dry, dead world we see today. Late in 2010, more than 6 years into its mission, NASA's Opportunity rover had already covered over 25 kilometers of Martian ground. It had rolled through dunes, studied craters, and found plenty of hints that the area used to flood now and then, but nothing proving a long-lasting body of water, like an ocean, had ever existed there. By this point, the rover was showing its age. A stuck motor meant it could no longer tuck its robotic arm away. Still, it pushed on toward its biggest target yet, a massive 22-kilometer wide crater called Endeavour, where orbiting satellites had spotted clay deposits. Clays matter because they only form when water sits in one place for a long time. After a few quiet months at a smaller crater, Opportunity worked its way toward Endeavour's rim, passing young craters with debris still scattered around them. When it finally reached a ridge called Cape York, the flat plains gave way to real terrain: peaks, ridges, and exposed ancient bedrock older than anything the rover had studied before. Interestingly, the ground here looked completely different from Opportunity's landing site. Gone were the tiny round pebbles nicknamed blueberries that had been everywhere before. Here, the rocks were sharper, coarser, different enough that mission scientists joked it was like getting a second landing site for free. The first rock it examined, nicknamed Tisdale II, turned out to be a fused mix of older rock fragments, carrying unusual traces of zinc and bromine, a signature that pointed to hot underground water once moving through the area. But the real breakthrough came just next to it: a thin white streak running through the rock, later confirmed to be gypsum, a mineral made of calcium and sulfur. Scientists named it the Homestake deposit. It likely formed when water dissolved calcium out of volcanic rock, mixed it with sulfur, and left the mixture behind in an underground crack that was eventually exposed at the surface. Later analysis showed this water was far less acidic than in other spots on Mars, meaning it could have actually been friendly to life. As Martian winter closed in, Opportunity parked on a sunlit slope to survive the season, in a spot called Greeley Haven. Once it could move again, it pushed on and eventually found something strange. More of those blueberry pebbles, but this time smaller, embedded directly in the rock, and chemically different from anything seen before. Scientists were stumped. The structure, composition, and distribution didn't match anything they'd cataloged. The rover's final stop was a pale rock called Esperance. It was unlike anything Opportunity had studied in its 9 years on Mars, rich in aluminum and silica, and clearly reshaped by long-term water exposure. This was the strongest evidence yet that neutral, life-friendly water had once existed on the Martian surface. In 2021, attention shifted to a new site, Jezero crater, home to a dune field called Seda, where erosion had exposed layers of rock representing different chunks of Martian history. Since Perseverance's drill could only reach a few centimeters deep, these naturally exposed layers were essential. Without them, older material would stay buried forever. But sand dunes are dangerous for a heavy rover. Getting stuck could end the mission entirely. That's where ingenuity came in the small helicopter riding along with Perseverance. It scouted the dunes from above, mapping a safe route through them before the rover risked driving in. Thanks to that aerial reconnaissance, Perseverance carefully threaded its way between dunes and reached a rocky outcrop called Brack without incident. By then, the rover had gotten good at drilling, and the samples it pulled from Brack surprised everyone. Instead of sedimentary rock, it had drilled into olivine, a volcanic rock formed from cooled magma, the same kind found in parts of Australia. That meant Jezero had once been volcanically active. At first, That sounds like bad news for the idea of life. But volcanic rock is often mineral-rich and combined with clear signs of water erosion nearby. It suggested that after the volcanic activity settled down, water moved in, creating exactly the mineral-rich, watery conditions life might need to get started. NOWTHE question, become this DID Mars have oceans? So let's find out. By now, scientists were confident that water had pooled in craters and carved out rivers. But the bigger question remained, did Mars ever have actual oceans? That question matters because shorelines are prime real estate for life. Unlike fast-moving rivers that constantly wash material away, shorelines concentrate organic molecules, encourage the formation of complex molecules like RNA, and offer steady energy sources like sunlight and heat, everything early biology might need. China's Tianwen-1 mission launched in July 2020, carrying an orbiter, a lander, and the Zhurong rover. After entering Mars orbit in February 2021, the lander touched down that May, and Zhurong became only the second rover in history after NASA's to operate on Mars. It landed in Utopia Planitia, the largest known impact basin in the solar system, an area later found to hide an enormous reserve of underground ice, roughly as much water as Lake Superior holds. Zhurong carried ground-penetrating radar, spectrometers, cameras, and weather instruments. Using its radar, it studied what was hidden beneath the surface by sending radio waves into the ground and reading how they bounced back whenever they hit a boundary between different materials. What stood out was that dozens of these underground reflections all sloped in the same direction, at the same shallow angle. Put together, that pattern revealed a buried, gently sloping stretch of terrain strikingly similar to buried beach structures found on Earth, like along the Bay of Bengal. The team ruled out sand dunes and lava flows as explanations, since both tend to slope in multiple directions. This one didn't. It pointed to a genuine ancient coastline, shaped by waves, tides, and a steady supply of river sediment. There's just one catch. Around 3.5 billion years ago, the sun was roughly a quarter dimmer than it is today, arguably too weak to keep Mars above freezing. Yet climate models still show rivers, lakes, and oceans on Mars during that same period. That contradiction is called the faint young sun paradox. Scientists have proposed three explanations. Maybe Mars had a thick greenhouse atmosphere trapping heat, though carbon dioxide and water vapor alone don't seem to be enough. Maybe Mars was only warm in short bursts, triggered by asteroid impacts or volcanic eruptions. Or maybe Mars was mostly frozen, with occasional melting events carving out the valleys we see today. None of these ideas fully explains everything we've found, though a study published in late 2025 found evidence that some of Perseverance's clay samples were shaped by long, steady rainfall, adding weight to the idea that Mars really did have periods of active rain. Unfortunately, we may not get final answers anytime soon. Perseverance spent years collecting samples for an eventual return to Earth, planned for the late 2030s. Including one sample NASA called the clearest potential sign of ancient life found on Mars yet. But after funding cuts threatened NASA's budget in 2025, the sample return mission ended up being canceled, even though the rest of NASA's funding was secured in early 2026. Those samples are staying on Mars for now, maybe until humans get there themselves. As for Zhurong, it was only designed to last 93 days, but kept working for nearly a full year before going dormant in May 2022. It never woke back up, likely buried under Martian dust. So the big questions remain. If Mars once had oceans, where did all that water go? Could something similar happen to Earth one day? And if life really did start along those ancient shores, could any trace of it still be buried down there, waiting? Our rover detectives have done their job. They followed the water. But whether life ever left a fingerprint on Mars is a mystery still waiting to be solved. Thanks for watching. If you enjoyed this one, consider checking out the Astrum Origin Patreon. It's what keeps these videos ad-free and keeps this channel going. See you in the next video.